Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for combination sum problem. Let's take a look at the problem description. We are given an array of distinct integers candidate and an integer target, and we have to return a list of all unique combinations of candidates where the chosen number sum to target, and we may return combinations in any order, and the same number may be chosen from candidates an unlimited number of times. And the two combinations are unique if the frequency of at least one of the chosen number is different. Let's take a look at the example 1. The candidates array has 4 elements 2, 3, 6, 7 and the target value is 7. So with these 4 numbers we can form a 2 combinations which sums up to 7. We can choose number 2 2 times and then choose 3 once, and we can get an array which can add up to value 7. We can choose only number 7 that adds up to the target value 7. The output has 2 combinations. In the case of example 2, the candidates array has 3 elements 2, 3, 5 and the target value is 8. So there are 3 combinations which can add up to 8. So if we choose number 2 4 times, that gets add up to 8. If we choose 2 once, 3 twice, that gets add to 8. And if we choose 3 once and 5 once, we get the target value 8. So the output will have 3 unique combinations. And in the case of example 3, the candidates array has number 2 but the target value is 1. So there we cannot form any combinations that can add up to value 1, so the output is empty. The constraints for this problem are the length of the candidates array is ranging from 1 to 30. The value of the elements in the candidates array ranging from 2 to 40, and all the elements of candidates array are distinct, and the target value is ranging from 1 to 40. Let's look at the approach to solve this problem. We are given the candidates array with 3 elements 2, 3, 5 and the target value is 8. The expected output have 3 combinations. One is 2, 2, 2, 2, 3, 3, 3, 5. All are adds up to the target 8. So basically we need to generate all possible combinations with these numbers that meets the condition mentioned in the problem description. Basically we can include the number any number of times, and also we need to generate only the unique combinations. Okay, basically the combinations are unordered. The combinations 2, 3 and 3, 2 are same. So let's see how we can generate the combinations first, and as we include the numbers, how we are following that rules listed in the problem description. Okay, so to begin with, we have the input array that has 3 elements and the target value is 8. So at this level we have 3 options to include. Okay, so we include 2, here we include 3, and in this flow we include 5. Okay, because we can include 2 unlimited number of times, again the input set has the number 2. Okay, so in this node we can include 2, 3 and 5, and here again 2, 3, 5 all the numbers are available. Okay, in this path, but in this node the input size is reduced. Basically we ignore the numbers that are present before 3 in the input. Okay, in this case number 2 is present, we exclude the number 2. Okay, so from here we can either include 3 or 5. So we include 3 and we include 5. In this third case 2 and 3 are excluded from the input because they are present before 5. All the numbers present prior to the current number are ignored. Okay, so that's why in this path only 5 is available to include in the combinations. So as we include, we also maintain a slate which contains the numbers included in this path as we go down, and also we maintain a sum variable which contains the sum of all the numbers present in this path so far. For example, at this layer the sum variable contains 2 because we included only number 2. At this layer in this path the sum contains 4. Here it contains 6. Here it contains 8. Once the sum and the target variable values are equal, then the slate will be added to the final result. So in this case 2, 2, 2, 2. So this combination is added to the slate. So that is here. And in this node we have two options 3 and 5. So we include 3 and 5. And in this node we have again 3 and 5 available. So when we include 3 here, the sum will be 2 plus 3 plus 3, 8. So that is equal to the target value. So that combination is added to the final result. And in the path which begins with 3, the options we have is 3 and 5. So we include 3 and here we include 5. So this adds up to 8. So the 3 comma 5 will be added to the result. So basically we maintain a slate which contains numbers added in that path and also a sum variable which keeps track of the current sum of all those numbers in the slate. So whenever we hit a node where the sum value and the target values are same, we add that slate to the result. And if the sum is greater than the target, then we backtrack. For example, let's consider this path 2, 2 and 5. The total is 9, okay, which is greater than the target value. So we backtrack. Similarly here 5 plus 5, 10. So we backtrack from this node. So that's what I have written here. So basically we can solve this problem using the recursion with backtracking. First we initialize the sum variable to 0 and initialize the slate with empty slice of int and initialize the result with empty slice of int. Okay. Then we call the helper function with the candidate input array and the target value and the sum variable and the slate slice and the result. Okay. First we check whether the sum is equal to the target. In that case, whatever is in the slate slice will be added to the result. Otherwise, if the sum is greater than target, we backtrack. Then we iterate over the numbers in the candidates array and then we create a new candidates array by excluding all the numbers that are present before the current number, and then we add the current number to the slate, and then we make a call to the helper function again with the new candidates array and the target value, and then current number plus sum as the sum, and then the new slate and the result. We do this recursively. At the end we have all the combinations which are adds up to the given target value. Let's take a look at the flowchart. Input for this procedure is the candidates array and the target value and the sum variable and the slate slice and the result slice. Okay. First we check whether the sum is equal to the target. If this is true, then we add that slate to the result slice. Otherwise, if the sum is greater than target, we backtrack. Else, we initialize the index to 0 and then we traverse all the elements in the candidates array in this for loop. In each iteration, we append the current number to the slate and then add the current number to the sum variable. Then we create a new candidates array by excluding all the previous numbers present before the current number in the candidates array and make a recursive call with the new candidates array and targets and new sum and slate and result. We repeat this until we process all the elements in the input array. And finally we return the result. Let's move on to coding. First I initialize the result of type slice of int and then slate of type slice of int and then the sum integer variable with value 0. Then I call the combination sum helper function with the candidates array, target value and the sum and the slate and then the address of the result slice. And finally I return the result. Next I write the combination sum helper function. First I check the base case, that is sum is equal to target. In this case, I create a copy of the slate and add this solution to the result slice. Then I return. Else, if the sum is greater than target, that means we do not have to proceed further. So we backtrack here. Then I write the for loop which traverse the elements in the input array candidates. It makes a call to the combination sum helper function with the candidates array excluding all the previous elements from the current element and the target value and the updated sum, which is including the current element in the sum, and then append the current element into the slate, then the result slice. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given the candidates array which has two elements 2 and 3 and the target value is 5. So the output should have one combination, that is 2, 3. So first we initialize the result slice of int and the slate slice of int and the sum variable to 0, and then we call the combination sum helper function with those values. So first the slate is empty, result is empty and sum is 0. Okay, and then we call the combination sum helper function. Okay, first we check whether the sum is equal to the target. In this case it is not, and then sum is also not greater than the target. So we traverse the numbers in the input array and then we call the combination sum helper recursively by updating the sum with the current number and append the current number to the slate. Okay, so when we make a call to this, we include number 2. So the 2 is added to the sum and 2 is appended to the slate. Okay, and again we check whether the sum is equal to the target and the sum is greater than the target. Both the conditions are false. So again we include the number 2. So the slate contains 2, 2 and the sum will have 2 plus 2, 4. So 4 is not equal to 5, 4 is not greater than 5. So again we go ahead and include 2. And now the sum has 6 and the slate has 2, 2, 2. 6 is greater than 5, so we backtrack. So we backtrack from here and then we have one more number to include, which is 3. So when we include 3, that sum will be 7. So the slate will have 2, 2, 3. So 7 is greater than 5. So again we backtrack. And when we come here, we have to include the number 3. So when we include number 3, the sum is equal to 5. 2 plus 3, 5, and the slate has 2 comma 3. Okay, so now the target is equal to sum, so the slate will be added to the result. Okay, and then we return from here. Control comes back to frame 1. Here we have number 3 is available to include, so we include number 3. Okay, the slate contains 3 and 3 is less than 5 and not equal to 5, so we again include the number 3, and now the sum is 6 and the slate contains 3 comma 3. So 6 is greater than 5, we backtrack and control comes back here, and finally this function returns back to the combination sum, and in the combination sum we return the result. Final result will have 2 comma 3, that is an expected output. Next I'm going to do the time and space complexity analysis for this solution. The time complexity for this procedure is order of n to the power h plus 1 minus 1 divided by n minus 1. So this is basically the number of nodes in the n-ary tree. Okay, so where n is the branching factor. So the total processing time we calculate by counting the number of nodes in the n-ary tree. So here n is the length of the input array. For example, here in the combination sum helper function, for each number in the input array we make a recursive call and branch from the particular node in the tree. Okay, so the branching factor is the number of nodes in the input array. So the height is calculated by dividing the target value by the smallest number in the input. So let's take a look at the case 1. So here the candidates array has 2 elements, 1 and 2. The target value is 3. So for this input, maximum height of the tree will be 3 divided by 1, 3. So the height will be 3. So using this formula, we can calculate the number of nodes in that n-ary tree with branching factor as 2 and the height is 3. So that is equal to 15 nodes. Okay. And in the case of example 2, we have 3 nodes, 3 elements in the input array, and the target value is 10. For this case, the height of the tree will be 10 divided by 5, 2. But the branching factor is 3. So in this case, the total number of nodes in that ternary tree is 13. So this is the worst case scenario because we are using a backtracking. Number of recursive call is reduced. So this is basically equal to the total number of recursive calls for the worst case scenario. Okay, but because of the backtracking used in this procedure, the number of processing is less than the total number of nodes in the tree, n-ary tree. So the time complexity for this is order of n to the power h plus 1 minus 1 divided by n minus 1. The space complexity for this procedure is order of t by s, where t is the target value, s is the smallest number in the input array. So basically this gives the height of the call stack. For this case, the candidates array has 2 elements, 1 and 2. The target value is 3. Height of the tree for this case is 3 divided by 1, 3. So in the case of 2, the height is 10 divided by 5, 2. Okay. So the space complexity for this procedure is order of t by s, height of the tree. Thanks for watching this video. Have a great day.